Hello again, and welcome to another wonderful lesson with Mr. Wheezy. Today we're going to be doing Lesson 6.6, Placing Figures in the Coordinate Plane. So, kickoff from last time, if you want the answer to that one, I'm going to let you guys look that up in those notes. But we're going to move ahead for now. The whole point of placing figures in a coordinate plane is to prove their lengths, slopes, all that stuff can all be found out without knowing any of the numbers. So this is kind of like one of them that we did last chapter. You guys all hated it because there was absolutely no numbers. Well, there's going to be more of that, and I'm sorry. But it'll be okay. We'll get through it. It'll be fine. So, starting with the art class is creating a t-shirt designed by drawing quadrilaterals. By connecting their midpoints, Tiana claims that they are making parallelograms. Is she correct? Well, this is what we're working with. So here they've placed the plane or the quadrilateral into the coordinate plane. Now, notice they start by putting the one corner on the origin. That makes it real easy because this point is going to be 0, 0. Like that point is going to help out tremendously. They also are putting one side along the x-axis. You want to do that. It's just, it helps kind of square everything up. Makes it easier to work with again. From there, this is where they're putting letters in to represent distances. Now, because we're a distance over and a certain distance up, they did A and B. Now, they are doubling this because that makes it a whole lot nicer when we're doing slopes and midpoints where we're cutting stuff in half. You definitely don't want to have fractions there, so this just takes care of all that by doubling that up. Same thing over here, we're another distance over, so we have to use C there. We're a different height, so we use another variable. We're using D, and then we're all the way over another distance across, so we use E, and we're on that x-axis, so we're 0. So from there, we're going to start by finding midpoint. Midpoint is where we take x1 plus x2 and divide by 2. And that's our first point. That's our x's. We do y1 plus y2 divided by 2. And that's the other side. So this is midpoint. Okay. So to find t, midpoint of A and O. So if we start with our x's would be 2a plus 0 over 2. And then our y's would be 2b plus 0 over 2. Well, adding 0 to anything is just itself. And then our 2's can cancel. So we're going to be at the point A comma B. Simple enough. On to W. Here we're going to get a little more complicated. X's would be 2a plus 2c over 2. Our y's would be 2b plus 2d over 2. Now, the one thing we can do is we can get rid of these 2's. And so we're going to end up with a plus c comma b plus d as our 2 points, our 2 coordinates. Not ideal, but we'll work through it. It'll be fine. V, over here, we're going to be between C and E. So 2C plus 2E over 2. The other side, we're going to have 2D plus 0 over 2. So again, anything added to 0 goes away, and then we can cancel our 2's out. So we're going to be left with C plus E, comma, D. For that one's midpoint. Lastly, for U, we're dealing with these. So 2E plus 0 for our x's. I don't know why I closed that in, over 2. And then 0 and 0 for our y's. So we're going to end up with the 2's canceling, 0 going away, E comma 0 for that last one. So, a lot going on there. And I know these points aren't ideal, but they're workable, and we'll get through it here. Next, we're finding slopes. Now, we're not going to find slope of TW and TW. This is a typo. This should be UV. So, slope. Slope formula is y2 minus y1 over x2 minus x1. So, if we find the slope of TW, T and W are top two here. We would do our y's first, which is b plus d minus b, over then a plus c minus a. Well, the negative b's and positive b would cancel. The a and the negative a would cancel. And we were left with d over c. So that came out a lot better than what it was kind of looking for. We need to show that our slope of UV is going to be the same so that we can show that these are parallelograms, because we have to show they're going to have the same slope. So we're dealing with the bottom two now, U and V. So we would have C plus E minus E for our bottom, and our top is going to be 0 or D minus 0. Well, the E's are going to cancel, and minus and 0 is itself, so we're going to end with D over C. Therefore, those two, TW, one right there, TW, and UV are parallel. And that's all we're really going to do there. So yes, she is correct. They are a parallelogram. Now, last part of this, I know, another short, simple lesson, kind of. What we can't see here is this is going to be A comma B at this point. So here they've just placed this rectangle where it's centered at the origin. So if you think about it, however far right we go, we're going to be the same distance left, same thing going up, same thing going down. We're centered so that everything's going to be going the same there. So it's the same kind of idea. Think this is the X, this is how far to the right, the B is the Y, how far up. So for M here, we're still going to go A across. We would go the same distance, but however, instead of up B, we're going to go down B and have a negative B. Over here at K, we're still up B, but we're going to go a negative A over. So we at negative A comma B. And here we're going left, so negative, and down negative, so negative A comma negative B. And that's how that one will end. So, usual spiel. Questions, comments, concerns, please message me with a PAN, an email, or Google Classroom. Whatever works best for you. If you had something that you kind of missed, go back through, rewatch the video. You can always pause the video if you need more time to write stuff down. Make sure you do all that. But until next time, we'll talk to you later.